Okay, so the last one, instead of using back substitution, we could continue with row operations to transform the augmented matrix to reduced row echelon form and get the solutions directly from that matrix. This technique is called Gauss-Jordan elimination. So you just keep going. So we're in row echelon form right here, right? We could keep going and zero out these other things, the top triangle, and put it in reduced row echelon form. And then you have y or x equals 6, y equals 3, and z equals 5. Notice row echelon form is not unique, but reduced row echelon form is unique. There's only one reduced row echelon form for each system. So, or for each augmented matrix. So let's do that. 2, 1, -1, -2. 3, -1, 0, 1. -4, 2, -1, -1. All right, so I first do these zeros. Those are first. Then these zeros are second. And then these zeros are third. So first, second, third. And then these ones are last. Unless it's easy to make. If they're easy to make ones, go ahead and make them ones. If they're not easy to make ones, don't do it until the very end so you don't have to have fractions all throughout your matrices. So right now, none of these are easy to make ones without making a fraction, right? So we're just going to leave them as twos. But we are going to eliminate these two, make those zeros. So I'm going to keep row 1. I'm going to do -3 row 1 plus 2 row 2 to be my new row 2. And I'm going to do 2 row 1 plus row 3 to be my new row 3. So 2, 1, -1, -2. -3 times 2 is -6 plus 3 times 2, which is 6, so that's 0. -3 minus 2 is -5. Positive 3 plus 0 is 3. And -6 plus 2 is 8. Right? Is that -6? Positive 6 plus 2 is 8. Then 2 row 1, so 4 minus 4 is 0. 2 plus 2 is 4. -2 plus 1, or minus 1, is -3. And -4 minus 1 is -5. All right, so column 1 is good except for that 2. We'll change that later. Okay, so we're going to keep row 1. Now we need to, oh no, wait. That's not good because we need to make those zeros. So now we need to make this 0 and this 0. So I can do 5 row 1 plus row 2 to be my new row 1. We're going to keep row 2. And then I need to do row 2 with row 3. So it's going to be 4 row 2 plus 5 row 3 to be my new row 3. So 10, 0, -5 plus 3 is -2. -10 plus 8 is -2. Row 2 is staying 0, -5, 3, 8. 4 times row 2, so that's -20, 0. -20 plus 20 is 0. 4 times 3 is 12, minus 15. 12 minus 15 is -3. And 2 times 4 is 32. Minus 25 is 7. Okay, so now we need these to be zeros. And we're going to have to use row 3 to make those zeros. Okay, obviously we don't want to make those zeros, right? We want to make these zeros, so let's try that again. Okay, we have to use both row 3 both times because we don't want one of these zeros, like we don't want that one to become a 1. So we're going to have to use row 3. So we're going to do, let's see, -3, row 3, or row 1, plus 2 row 3 to be my new row 1. Then we're going to do row 2 plus row 3 to be my new row 3. Then we're just going to leave row 3 alone. So -30, 0, hopefully 0, right? +6 minus 6 is 0. And then +6 plus 7 is 13. Oh, plus 14, sorry. All right, so +6 plus 14 is 20. Then 2 row 2 plus, or sorry, row 2 plus row 3. So 0, -5, 0, 15, and then 0, 0, -3, 7. Now, looky, we're almost in reduced row echelon form, right? So now we need to do -1/30 row 1 to my new row 1. And then -1/5 row 2 goes to my new row 2. And then -1/3 row 3 goes to my new row 3. So 0, 1, how about 1? 1, 0, 0. 20 over -30 is -2/3. 0, 1, 0, -3. 0, 0, 1, -7/3. So my solution's -2/3, -3, -7/3. This is my reduced row echelon form. And done, solved. Okay, I think Mr. Blackburn has done a video on the last one, so I'll check and make sure. If not, I'll do one. Otherwise, you can watch his. All right.